So the first thing I'll do is to rewrite this and isolate x. And what I'm going to do is to write these as largest terms that are divisible by 2. And what that means is 99, I'll do 100 minus 1. So I'm taking out the part, the largest piece that's divisible by 2, because I'll isolate x. And here I'll do minus 4y, y. So then x would be 100 minus 4y, which is divisible by 2, and then I'm left with y plus 1. This piece becomes 50 minus 2y. And why am I doing it this way? Well, this is integer already. So all I need to do is to look for y values that would make x an integer. And you'll see immediately y just needs to be odd, because odd plus 1 would be even. And what's the least value? Well, they say it has to be greater than minus 20. So minus 19 is the least, minus 17, minus 15, and I have to see how far I can go. And I can compute the corresponding values of x either by plugging it in here. So if we do it here, for example, this would be minus 18 over 2, so 50 plus 38, and then this would be 9, so 97. And then the next value here would be 5 less. Why? Because you'll see the change, the delta x, I should say delta 2 times delta x is equal to minus 5 of delta y. So change in x over y is minus 5 over 2. So that's changing by 2, so that's going to go by, it's increasing by 2, so that's going to go down by 5. So, I mean, you don't have to generate all of these, but that's the pattern. The key thing is, how far do we go so that we still satisfy that condition, x is being greater than or equal to y? So to kind of estimate that, one way is you can just try different values. For example, I mean, I did this, I said if y is minus 1, well, that's 0. In this case, x is 50 minus 2 times minus 1, so it's 52. So I still satisfy this, so I need to kind of go far out. So you can do a trial and error, or you could say x I know is 99 minus 5y over 2. And since that needs to be greater than or equal to y, this inequality would tell me what's the constraint on y. So 99 minus 5y, 2y, so that becomes 7y is less than or equal to 99, or y is less than or equal to 99 over 7, which is 14 times 7 is 98. So what's the largest odd value of y that would satisfy? That's 13. So we'll go all the way down to 13, and you can check. I'll plug it back into this. So 2x is 99 minus 5 times 13, so that's 65. 99 minus 65 is 34 divided by 2, so x is 17, and you'll see x is indeed greater than y, and they're both greater than minus 20. If you go to the next higher value of y, this would go up 2. That will go down by 5, so this would actually become 12, and this condition is no longer satisfied. So this case is out. These are the only possible cases. So we're going minus 19, minus 17, all the way to 13. This is an arithmetic progression difference of 2, so number of terms would be last minus first divided by the spacing, which is 2, the common difference, plus 1. That's 32 over 2 is 16 plus 1. We have 17 such pairs, and that's the answer.